All right, so in this video, we are going to just review factoring. The different types we've talked about in this first section. And this can be if you missed, if you just need extra viewing, whatever. Okay, so let's first talk about GCF, the greatest common factor. This is actually the first step of any factoring. You might use GCF along with the other ones that follow in this video, but it's always the first step. You should always check and see if you can do something to simplify your factoring, and sometimes that's all you can do. Okay, so let's take a really easy one, such as this: 40x squared plus 80x. Now what you're going to do is you're going to look at two things. You're going to look at the numbers, and you're going to look at the variables. And you're going to see, is there a number, the greatest number, that can come out of 40 and 80? Well, obviously 2 can come out, and you might recognize 10 or 5 or 4, but we really want the biggest number, and that's going to end up being 40. Okay, 40 is the largest number. X squared next, there's a little secret here. You want to actually pick the smallest exponent because that's the most we can take out. Okay, we can take 1 from 2, but we can't take 2 from 1. So we cannot factor out an x squared because there's not enough x's here. So the biggest amount, the greatest amount of x's we can take out is just 1x, x to the first power. And then we just divide. 40 divided by 40 is 1. Not necessary to put that, but you can. X squared divided by x is just simply x. And then 80 divided by 40 is 2. It's a positive 2. And the x's cancel. X divided by x. And remember, if you ever need to, you can always simply do this and go, oh, 2 minus 1 and x to the 1 over x to the 1. Oh, they cancel, leaving you just 1. Okay, so that's something you can do. So that's a very simple. All you can do is take out GCF, and that was it. Let's try another one. Somewhere along those lines. 10b cubed plus 5. So again, we're going to look at the numbers first, 10 and 5. The biggest number we can take out is a 5. But then the b's. There are no b's here. So we can't take any letters out. There are no common b's in the two places. So therefore, all we can take out is a 5. And then we divide. 10 divided by 5 is 2. The b cubed just drops down. And this, be careful. Some people go, oh, it's just 2b cubed. The 5's cancel. No, 5 divided by 5 is 1. We need that placeholder. Okay? So I will real quickly show you this. This is a very common mistake I see over the years, people doing something like this when something cancels. But here's where you go back and check. 5 times 2b cubed. Does that give you 10b cubed plus 5? No, it just gives you 10b cubed. So you can always check and make sure you get your first starting problem if you multiply back through. It's a good safety check. Okay, let's go up to a larger one. How about this? 80x cubed. Now let's go to the fourth. 80x to the fourth minus 10x cubed plus 90x. So again, we look at the numbers. The biggest number that goes into all those is 10. We're going to look for the smallest exponent. So we're just, all we can take out is x to the 1. We can put the 1 here or not. We don't have to. And then we just put our parentheses. And if we have 3 items here, we should have 3 items in the parentheses here, even if it's just a 1. So 80 divided by 10 is 8. X to the 4 divided by x to the 1 is x cubed. X to the 3. Negative 10 divided by 10 is negative 1. We can put it there. We don't have to. X cubed divided by x to the 1 is x squared. And then 90 divided by 10 is plus 9. And there is no x there. Okay? Because the x's cancel. That's it. Now, that's a straight GCF one. We'll come back to a GCF inside some of the other ones, but that's it for GCF. Okay? Now let's go on to difference of squares. I'm just going to abbreviate this like this. Difference of squares. That means difference means subtraction, and squares means you have to have a perfect square number or a variable. Okay? So for example, if I had 16x squared minus 25, it's a very simple strategy. You're going to have two sets of parentheses. You're going to have 1 plus, 1 minus, and you literally just take the square root of everything. Square root of 16 is 4, so you put a 4 here and here. Square root of x squared, x. Square root of 25 is 5. And you can multiply this back out and see 4x times 4x gives me this. 5 times negative 5 gives me this. And when I multiply this, I get 20x, this negative 20x, and therefore they cancel, leaving me just the 16x squared minus 25. Okay? How about something like this? This is one that throws people off also. 4x squared minus 1. This is where people want to just lose the number. Okay? Again, we have subtraction. Perfect square, perfect square, perfect square. Two sets of parentheses. 1 plus, minus, 1 plus. Doesn't matter which one's first. And you just take the square root. You just take the square root, and you just take the square root. Okay? Now, let's take something similar to that, but throw in the GCF. In fact, I'm going to take the same problem and just do 40x squared minus 1. Sorry, 10. Now, when I look at this at first, I go difference of squares. Well, that doesn't work because this is not perfect and that's not perfect. But remember, always check GCF first. What can I take out? Well, I can take out a 10. That will give me 4x squared minus 1, which is the same thing, and it's almost the same answer, except we have to bring this 10 down. Because if we don't, we'll just have 4x squared minus 1, not 40x squared minus 10. So this ends up being 2x minus 1 and 2x plus 1, just like before. The only difference is we couldn't do that without taking out this GCF right here. Okay, now let's get into trinomials. Tri means 3, which means we're going to have 3 terms here. Okay, separated by a plus and a minus, or 2 pluses or 2 minuses, whatever. Okay, so trinomial means 3 terms. Okay, so let's just take a basic trinomial. X squared plus 4x plus 4. Okay, now when we do this, we're going to break it down into 2 binomials. Now we have to look at a few different things. First off, we need to look at this term right here. Think about how we get this term, the last number. We get it from multiplication. Okay? The only way to get a positive number multiplication is a positive times a positive, or a negative times a negative. Which means these parentheses have to be both negative or both positive. Have to be. If this is positive, they're both the same. What tells us what they are? This right here. If that's positive, they're both positive. If that was negative, they'd both be negative. Okay? Now, when this is just 1, this is very simple. It's just x and x. And then to get 4, we're looking at 1 times 4 or 2 times 2. And we need these to add up to the middle term. Well, if we put 4 and 1, and this is called guess and check, and it's not guess and hope or guess and pray, it's guess and check. And I encourage you to always do 2 smiley faces. This gives you 1x, that gives you 4x. If we add those together, we get 5. We want 4. Very simple. We just go back, erase, and try again with 2 and 2. This gives us 2. This gives us 2, which gives us 2x technically, which gives us 4x. And that's our answer. Okay? Now, real quickly, if I went back to this and made this minus 4x plus 4, it's going to be almost the same thing. It's just the difference is, no pun intended, is that my 2 times 2 is still going to give me 4. 2 plus 2 is going to give me 4, but I wanted to add up to negative 4, so they both have to be negative. Negative 2 plus negative 2 is negative 4, but negative 2 times negative 2 is positive 4. Okay, so that's a basic trinomial right there, with the first number being 1. Okay, very simple. Try one more of those. And remember, if at any point you're feeling like, oh, I get this section, you can fast forward. You're in control of this. Plus 8x plus 12. Okay, so here we're looking for two numbers again that multiply to give me 12 that add up to 8. This is going to be x. They both have to be positive. And I'm looking at my factors of 1 and 12, 2 and 6, 3 and 4. Well, these add up to 8. But again, check your work. 2 plus 6 is 8. And that's what we want. All right. So let's mix it up with a subtraction problem here. Let's do x squared minus 6x minus 27. Now notice that this is subtraction over here, negative 27. The only way we did that is 1 plus or 1 minus. Okay, positive times a negative equals a negative, and negative times positive equals negative. So my two numbers, again, 1 times 1 gives me that. But now they have to differ by 6. So instead of adding the numbers, I need to subtract them. So 1 times 27 and 3 times 9. This is a pretty simple one because there's only two possibilities. Whoops. And 27 minus 1 is 26. 9 minus 3 is 6. So that gives me my two numbers. And here's where the smiley faces come in. And this is where the most common mistakes happen in algebra. Is people just go, well, one's positive, one negative. Let's just throw the sign in there and move on. Okay? Well, here's why it's called guess and check again. If I check it real quick, this is 9. That's negative 3. That gives me 6. I don't want 6. I want negative 6, which means this should be positive. That should be negative to give me negative. So my signs are flipped. I want my larger number 9 to be negative. Okay? Now, let's move on, step it up a little bit. And let's have a trinomial like that, but also has a GCF. So for example, 6x squared plus 36x plus 48. Okay? Now, I could actually break this down right now. The problem is I'm making it difficult on myself because here I need to deal with the factors of 6 and here 48. It's doable, and we will do problems like this where it does require more work. But in this case, if you would have taken the time to do the GCF first, watch how much faster and easier this problem would be. If you notice that 6 is a common factor of all of these, and we just divide, well, look how simple that is now. We're still going to break this down like we did before. X times x. Now I only have 1 and 8, 2 and 4. They have to add to 6, positive 6. That means I'm going to use 2 and 4. Both positive. And the only thing you have to remember is to bring this down. Because otherwise, I get x squared plus 6x plus 8 and not my original problem. But look how much easier it is if you take the GCF out. Now, it won't always happen. We will have problems. We're going to go to those right now where we have to do factoring with the number in front of the x squared. But if you check the GCF first, it might be a lot easier. All right, and last but not least, we're going to have a number in front of the x squared, such as this, 10x squared plus 17x minus 20. Now, this requires a little bit more guessing and checking. Move this over here. Because we're going to have a difference and we have more possible numbers here. So again, we know we're going to have two binomials, but I need to look at my factors of 10. 1 times 10, 2 times 5. For 20, 1 times 20, 2 times 10, and 4 times 5. Now, there's two sets of numbers over here and 3 over here. So you could have 1 and 10, 1 and 20, 1 and 10, 20 and 1, and so forth. All those different combinations of numbers. Usually you want to check at the less extreme ones. That may not be. It may be 2 and 5 and 1 and 20. You never know, but it's usually a safer bet to start there. So I'm just going to I'm going to go 2x and 5x. But this is where the guessing and checking the smiley faces is super important. Now, I'm going to pick 4 and 5. It doesn't matter where I put them. I just need to pick somewhere to put them. Okay, so I'm just going to do like I said, 4 and 5. Okay, now I need to check. Don't just assign stuff and move on. 4 times 5 is 20. 2 times 5 is 10. 20 minus 10 is not 17. So that is not correct. It's simple. You just erase and try it again. Not a big deal. 5 and 4, you might get it in 1 try. You might get it in 2 tries. It might take 4 tries. But it's basic math. You have an eraser. Just be patient. So here I have 5 times 5 is 25. 2 times 4 is 8. Oh, look at that. 25 minus 8 is 17. Now, since I want the 17 to be bigger and positive, I want the 25 to be positive. So that came from 5 times 5, and I want to do minus 8. So positive 25 minus 8 will give me positive 17. And again, here's my negative 20. Here's my 10x squared. Quick check. That's simple. Okay? Let's try another one of those. 9k squared plus 23k. This time we're going to do a plus 10. So this time they're going to add up to 23. So again here, 1 times 9 and 3 times 3. Not a lot of possibilities. Not a big deal. Here, 1 times 10, 2 times 5. So I'm going to go with 3x and 3x to start with. It may not be the right thing, but I'm going to go with it. And I'm going to check 2 and 5. Okay, that will give me 10. Well, this gives me 6. This gives me 15. That adds up to 21. Not good enough. No big deal. 5 and 2. Well, that's going to give me 15 and 6 again because it's 3 and 3. So switching it, not really worth my time. So I either got to go with the 1 and the 10 or the 1 and the 9. While they're written, let's just go with the 1 and the 10. Well, that's going to give me 3 and 13. That doesn't work. So I need to go again. Sometimes this happens, but I know it can't be the 3 and 3 because I exhausted both of these with 3 and 3. So let's go with 1 and 9. So 1 and 9, 2 and 5. 2 times 9 is 18. 5, and that's 23. Oh, I picked right that time. And they're both going to be positive. Okay. And now let's try one more with a little bit of everything. 4x squared minus 6x minus 54. But I noticed that these are all even numbers. 4 doesn't go into 6, but 2 does. So I'm going to make it a little bit easier on myself and divide everything by 2. 27 smaller, fewer factor pairs in 27 than 54. Here, it's only 1 and 2 instead of 1 and 4 and 2 and 2. So I've made my life simpler by taking out that 2. Don't forget to bring the 2 down. And now here I go. I know it's got to be 1x and 2x. That's nice. And I'm going to try 3 and 9. Remember, they differ by 3, specifically a negative 3. So this is 6. That is 9. Well, I cut a little bit of a break there. I got it right the first time. Now I want negative 3. I get that from 6 minus 9. So I want the 9 to be negative and the 3 to be positive. And there's my answer. And that is a summary of all the factoring we've done so far.